Okay, so today we'll be starting about routing, and so I'll be giving basic introduction to routing. Routing is the process of forwarding traffic from one network to another network. So I'll just display some things. It'll be these routers are layer 3 device, and this is a network layer, and we know that it is having a table called routing table, and it is more intelligent and sophisticated device because it is working based on the unicasting. So coming to routing is the process of forwarding traffic from one network to another network, and we have router, routing table, and routes, and there are two types of network: unknown device, known device. You guys can look at all these things. And coming to static versus dynamic, so static is nothing but we are going to configure everything manually, and dynamic, which is assigned automatically. So we'll be studying about in routers. Coming to routers, in routers we have two types. So we have two types. So that is manual routing, manual routing, and dynamic routing, dynamic routing. So in manual routing we have two types. In manual routing we have two types. One is static routing, and one more will be default routing, default routing. Okay, so coming to dynamic routing, in dynamic routing we have two types. So that one is IGP and EGP. So IGP is nothing but interior gateway protocol. EGP is exterior gateway protocol. IGP is nothing but interior, which is going to enable the communication within the autonomous system. So it will be within the autonomous system. But coming to EGP, it will be exterior gateway protocol. It will be communication will be exterior autonomous system. So in manual means manual, as I told, we are going to do everything manually. Like uh, like network administrator, he's gonna do everything manually. But coming to dynamic routing, everything is automatic, as I told. So I'll be discussing few points about static routing. So static route static route is a route that the network network administrator manually manually enters into the routing table. Okay, and so advantages is like, first advantages will be like the route is permanent. So because we are doing everything manually, the route is permanent. And coming to second advantage, most secure, it is mostly secure than dynamic. Again, coming to third point, so this is best suitable for this is best suitable for small networks. Okay, this is more secure than dynamic. And Third point is like this is best suitable for small networks, as I was telling. So third point will be best suitable for suitable for small networks. Okay, but all these are the advantages what we were discussing now. So coming to disadvantages disadvantages of static routing will be like, first point will be like this is not suitable for large networks, not suitable for large networks. Why it's not suitable for all large networks? Because when we have 100 routers or 1000 routers, we have to sit and do manually everything. But when it's coming to dynamic routing, it is done like it is done everything itself. Like it is going to assign IP address, subnet mask, default gateway. Everything will be done by dynamic. But in this manual, in static routing, we have to do everything like we have to go configure everything, like network administrator manually need to enter everything in its routing table. And this is permanent also, this whatever he is doing. And because it is not changing, whatever we are doing manually, it is permanent. And this is more secure also than dynamic, because in dynamic it keeps changing, but here there are everything manually, whatever we enter it will be permanent. And this is only best suitable for small networks, when like some 20 or routers or something, we can do it like it's like we can do everything manually. But coming to disadvantages, like it is not suitable for large networks, we cannot do it. And second disadvantage is like if the link gets failed, it will it will affect the entire entire network entire network. And your router cannot decide the alternative or alternate route for the data packets for the data packets to be transmitted to be transmitted. So coming to this manual route, like what are the disadvantages I was discussing? This is the disadvantages. So in disadvantages, as I told, it's not suitable for for large networks. And if one link get affected, complete network is gonna fail. Like example, I'll just show you. Like you think we are having three routers, and we are having three switches, and it will have one PC. I'm just giving small example. So these are connected. So this will be the PC1, sorry, router 1. This will be router 2, and this will be router 3. And this is PC1, and this is PC2. This will be PC3. Okay. See, if some issue with this R1, like R1, you have made manually some error, like you have configured its IP address wrong, then if this link gets failed, it is going to affect the entire organization. If one link gets down also, it is going to like affect the complete organization. So same thing I was telling, the disadvantage. The link gets failed, it is going to, like, it is going to affect the entire network, and this router cannot decide the alternative route for the data package to be transmitted, because routers are not going to decide anything, because network administrator is manually doing everything here. So this is a disadvantage coming to the static routing. So like first we'll be discussing about static routing. Static routing comes under in manual routing we have two types. One is static routing and is default routing. In dynamic routing we have two types, IGP and EGP, that is routing. And in IGP we have RAPE, OSBF, and EIGRP, and in EGP we have BGP. So we'll be discussing about these things later. So this is about static routing, and I will tell the modes. What are the modes in? Okay, so I'll be discussing the modes. Modes in router. So we have three modes. So first mode is idle mode. Idle mode. So this idle mode is like a sleep mode. It is mostly like a sleep mode. And second one is enable mode. Enable mode. So enable mode, we can run all the show commands. We can run all the show commands. Show commands, and this mode is used for troubleshooting purpose. This mode is used for the troubleshooting purpose. Okay, again coming to third mode. Third mode is a idle mode, enable mode, and configuration mode. Configuration mode. So this mode is used to run all the configurations. Okay, so we have three modes. One is idle mode, enable mode, and configuration mode. So idle mode is like a sleep mode, as I told. It will be like router, this greater symbol, this represents the idle mode. In this mode you cannot run any commands. It is like a sleep mode. So if you want to get, like, come to the enable mode, you have to type enable is enable. Shortcut, you can just type en. Then if you're typing en, you will get into the second mode, that is enable mode. So now router, you will get into slash, you are in enable mode. This is the enable mode. So this mode you can run all the show commands, like show IP interface brief, show IP route. It is gonna show, like, it is used for all the troubleshooting purpose. So from this mode you want to get into the configuration mode, you have to type configuration terminal. CONF config terminal. So it is configuration terminal. So you can just type CONF. So now you will get into the configuration mode. So you'll get into router configuration mode. Now you're in configuration mode. So slash. So now you're in configuration. In this mode you can do all the configurations. So now first, now you'll have 100 routers in your organization or 50 routers. So now I'm going to give unique name to each and every router. So I want to configure some router. So I'll take it as host R1. I'm giving specific name to that router. Again, now I'm in configuration mode itself. So now again I'm in configuration mode itself. So I'm in configuration mode. Now I'm going to configure it interface. Interface is like G0/0. We have to look which interface is that. It's 0/0, 0/1. Okay, so interface you have to look. If somebody don't know what is interface, see this interfaces connects connects routers and switches to each other. These are gonna connect routers and switches to each other. So next, interfaces will be identified by interfaces. Interfaces are identified. Interfaces are identified by both by both the type both the type of interface both the type of interface and interface and interface number. Okay, interface and interface number, and which will always begins with 0, which will always begins with 0 0 in Cisco devices. Okay, that is about interfaces. So now here I was coming here. Okay, fine. So now first I gave the host in configuration mode. I gave host. Then I must configure interface. Like interface, we can give shortcut int interface. Now I will take its IP address. Its IP address, interface IP address. I will just give example like it was 192.168.1.100, and its subnet mask is 255 dot. It's class C, so I'm taking 255.255.0. So next it will be like we are shutting, no sh, no shutdown, so no sh. So this is the three modes I need to explain. So I'll just be moving to static routing. So what is this static routing? So I was explaining all these things. Routing is the process of forwarding packets from one network to another network, choosing the best path from the routing table. Like we have the three routes, it will choose which is the best path. And routing makes possible the communication between two or more different networks. And routing table consists of the best route to the destination. So we have types of routing. We have three types, that is static routing, default routing, and dynamic routing. So in manual routing, I told static and default is coming. In dynamic routing, we have EGP, IGP, BGP. This is different routing. We'll be discussing later. So coming to static routing. This I told all these things. It is configured manually by the administrator and mandatory to know about the destination network ID, and the administrator must really understand the internetwork and how each router is connected in order to configure router directly. And this routing has to be done manually for every destination. We have to do routing for every destination because static routing we are doing everything it manually, right? Next, this static routing is used in a small organizations as I discussed, and network change can affect complete network. This is going to affect the any change in the small network, small interface is going to affect complete network. And the static routing, it is secure and fast as well. And AD means administrative distance value of static routing is 1. So this is the configuration of static routing. Like we have static routing, we are going to configure routes to reach each and every unknown network. We are going to configure for the unknown network on each and every routes manually. So for that, command is like IP route, and we are going to discuss about unknown network ID and destination subnet mask, next stop IP. Then we are going to give exit. So these are the commands used to check like whether it's connect. Ping is a tool to check the connectivity, and tracers is the tool it's used to check the like it's going to trace the traffic from source to destination. So like now I'll be going to the packet tracer and we'll just be doing it. We'll be doing with the lab. Mm. Okay, so now first I'll give a small demo, like how this all these are the routers. So all these are the routers, and like we'll be using 4311 series, 4321 series, 1941 series, and 2901, 29 all these are the series of routers. And next we have switches. So all these are the switches, and this is layer 3 switch. Layer 3 switch, it acts as both router and a switch. By default, routing will be enabled in the switches. If you want, sorry, if it will be disabled, if you want you can enable the routing. So these are the end devices. We have PC, laptop, server, all these things, and these are the cables. Okay, so now I'll take a router. So now I'll take 2911 series router. You can press control and select the routers, how many routers do you want. So getting to back to this mode. So I'll move to the switches and I'll connect the end devices and I'll connect the cable. Okay, fine. So this network I'll consider as 192.168. I'll take it as 1.0 network, and this one I'll consider as 192.168.2.0 network. Okay, fine, done. So now I'll just configure this single interface. We will just leave the second router. So first I'll be configuring the, so this is R1 router and this will be the R2 router. Okay, so here I'll be considering now R1. So I'll go configure R1's end devices and its interface. So I'll go to R1. So this is 1.0 network. So first PC will become 1.1 and second PC will become 1.2. So I'll go to PC1, go to desktop, IP configuration. So it will be 1.1. IP address will be 192.168.1.1 and its subnet mask will take automatically, and default gateway will be 192.168.1.100. I'm just considering 1.100 default gateway. So coming to PC2, even it will have the same default gateway. If you're having 10 end devices also, you have to take same default gateway. So coming to PC2, IP configuration, IP address will be 192.168.1.2 because it's a 1 dot network. Second PC will become 1.2. Subnet mask default gateway will be 192.168.1.100. So this is the default gateway. So now, as I told, I'll configure this first router interface. So I'll go to this. I'll just remove this interface. So I'll focus only on this router now. So I'll get into this router. So would you like to enter the ensure configuration dialog? No, I don't want to. So now it is in idle mode. As I told, idle mode is a like a sleep mode. We cannot do anything here. So I'm going to get into enable mode. En. See, now I'm in enable mode. So this mode is used to run all the show commands as I told previously. So I'll get into the configuration mode now. Configuration terminal. So now I will give specific name to this router. So I'll give host R1. So now it is in R1. So I'll configure its interface. Interface is JIG 0/0. As I told, interface connects routers and switches with each other. See, interfaces are connecting routers and switches with each other, and these are identified by both interface type, like name and number. Like you can see JIG also, and it is identified with 0, and it will always start, it will begin with 0 in Cisco devices. As I told, you can see it is beginning with zeros. 0, it is beginning with 0, 0/0, 0/1, 0/1. You can just see all, it's beginning with 0. So this is gigabit. So gigabit is faster compared to Ethernet and fast Ethernet. So Ethernet is only 10 Mbps, but compared to like fast Ethernet it is 100 Mbps, but gigabit Ethernet it is 1000 Mbps. So this gigabit is fast. So now I'm going to configure its interface. So its interface is JIG 0/0. Now its IP address. Its IP address is 192.168.1.100, and its subnet mask is 255.255.255.0. So I will give no shutdown. So now the link changed to up state. So coming here you can see it was in red color and now changed to green color. So now I'll try to connect these both devices. So I'll go to command prompt. I'll try to ping to 192.168.1.2. See, I'm getting a reply. Ping is a tool to check the connectivity. So I'm getting a reply. So now this is passing the connectivity because it is in the same network and they are connected, and this 1.1 knows about 1.2, and this router knows about 1.2 also because it is in the same network. So now we'll try to connect to our same thing we'll do to our router 2. So now I'll go to cable, connect it. Okay, so now I'll try to configure first this end devices. It is 2.0 network, and I'm going to configure it as 2.1 and 2.2 because 2.0 network first PC will be 2.1, second PC will be 2.2. So it is 192.168.2.1, and its default gateway is like 192.168.2.100. Coming to PC2, it is 192.168.2.2. So this is 2.1. You can see this is 2.2, and we didn't configure its default gateway. It is 192.168.2.100. So this is the default gateway. So 2.100. So now we'll configure the interfaces. So now R1 is having one more interface. It is connected to two interfaces. You can see here it is JIG 0/0, and here it is JIG 0/1. So I'll go to R1 interface JIG 0/1. So I'll take this as 10 dot network. I'll consider this as, you can take anything, 10, 11, it's left to you. 10.0.0.0/20. No, it's not 20. Okay, we'll just consider as 10.0.0.0. It will be /8. Okay, so I'll come to this and its IP address is 10.0.0.1, and its subnet mask will be 255.0.0.0, and no shutdown. Now the link has changed to up. You can just click. It takes some times to forward the traffic. So now we'll go to R2, we'll configure jig 0/0 and 0/1. Come to R2, no, and enable and configuration terminal and interface. Okay, first I'll give the host R2, and its interface is G0/0. First I'll configure 0/0 interface G0/0, and its IP address will be 192.168. Sorry, it is not 192. So this is jig 0/0 is 10.network. This will become 10.1 R1. R2 will become 10.2. Right? So it will be 10.0.0.2, and its subnet mask will be 255.0.0.0, and no shutdown. So now the link changed to upstate. You can just look, it is changed to the green color. And now coming to this interface, need to configure jig 0/1. R2 interface jig 0/1, and its IP address is 192.168.2.100. IP address is 255.255.255.0, and no shutdown. Yeah, now the link changed to up. If you want, we can go verify it. Exit. So I'll verify it. Just get it. Exit. So I'll verify it. Show IP interface brief. So now you can check 0/0. This 0/0 is configured with 192.168.1.100, and it's manually up. And you can check 0/1. This is 10.0.0.1. Yes, and it is also manually up. So coming to this, also I'll just verify it. Exit. So I'll come to the show command. Show IP interface brief. So we can check 0/0. This 10.0.0.2, and coming to 0/1, it is 2.100. You can see 2.100. It's manually up. So now I'll try to connect from 1.1 to 2.1. So I'll try to connect from 1.1 to 2.1. So reply from 192.168.1.100. Destination host is unreachable. Why? Because this network doesn't know about this network. Right? See, this R1 is connected to G0/0 and 0/1, but it's not connected to 0/1 or 0/0 or 0/1. This one it's not connected. So obviously they will not reach. They cannot reach the packets. This PC is sending the packet to the router. This router will check its destination. Like this router doesn't have. See, I will check show IP route. See, this route doesn't know about this 2.0 you can see it is connected to 10.0.0/8 and 10.0.0.1/32 and 1.0 1.0 1.100. It's connected only, it's connected, and this is the local L is nothing but, you can just local L is local, C is connected, so it's locally connected to this 1.100, connected to 1.0, but it doesn't know about 2.0 network or 2.100 network. Obviously the destination will not reach. We'll try to connect from this network 2.22. So I'll try to ping to 192.168.1.2 from 2. Network. So obviously the network will not reach because they doesn't know the way. How should I reach? Right? See, request is getting timeout and host is unreachable. So for that purpose, we are going to configure the static routing. So static routing, we are going to configure the routes to reach every unknown network on each and every routers manually. And so first we have to give IP route, and which is the unknown network. Next we are going to give destination subnet mask, and next hop IP is router's next IP address, and next we are going to give exit or end. And these are the commands for the verification. So we have to check interface, you can use show IP interface brief, and to display the routing table you can use show IP route, And to display the connected network information, we can use show IP route connected. And to display the static routes from the routing table, we can use show IP route static. And to display the single network information from routing table, we can use show IP route and its particular. If I want to check particular routing table, I can check using particular ID. And show interface, if you want to check specific interface details, you can just give specific like interface details, and you can check. And check IP address in PC, you can use IP config. It's going to check. You can check the IP address. So now we are going to do static routing. So it is command is like IP route, unknown network ID, destination subnet mask, and next hop IP address. So I'll come here. This I have to give first. Now I'm going to configure static routing. So I'll get into configuration terminal mode. So now I'm in configuration mode. So first we have to give IP route. I give IP route. Then we have to give unknown. Here you can see we have to give the unknown network ID, which is unknown network, and this unknown destination subnet mask, and we have to give next hop IP address. Clear? So I'll come here. Coming to R1, R1 doesn't know about this C, which is not connected. See, R1 is connected to this network and this network. It knows about this both, but it is not connected to this network. So this will be the unknown destination. So this will be the unknown destination for R1. Okay. So R1 doesn't know about 2.0 now. So I'll go to R1 and it doesn't know about 192.168.2.0. It doesn't know about 2.0. And its subnet mask is 255.255.255.0. Now R1, this R1 wanna reach R2. So this router's next next hop means router's next IP address. So this is router next hop IP address will be 10.0.0.2. So if router knows this way, it can reach this network. So next hop will be 10.0.0.2. Coming here, I will give next hop is 10.0.0.2. So now I will end or exit it. So now it is configured. Now we can check show IP route. You can see S is nothing but static. You can just look. S is, they will ask in interviews what is S, what is R, what is O, what is N2. So you need to know all these codes. So S is static. So now S connected to 2.0 via, it is going via 10.0.0.2. This is the next top IP address. Okay. Now coming to R1, sorry R2. R2 doesn't know about this network now. R2 doesn't know about. Okay, now R2 doesn't know about this net. R2 doesn't know about R1, right? Okay, so we'll go to R2 configuration terminal. So it doesn't know we have to give IP route first. It doesn't know about 192.168. It doesn't know about 1.0, right? Its subnet mask is 255.255.255.0 and next hop IP address. R2 wanna reach R1. So router's next IP address will be 10.0.0.1. So next hop will be 10.0.0.1. Now it got configured. So now we'll try to connect. So first we will get request timeout because it takes some time. ARP is nothing but address resolution protocol, where it is resolving its IP address to the MAC address or physical address. So it takes some time. So now we are going to get late reply. So see, now we are going to get immediately. So now 2.2. See, I'm getting a reply. So I'll go to this network and I'll try to ping to 1.2. See, now I'm getting a reply. See, so done. So that's all about static routing. Thank you.